welcome back to my channel. I hope everyone is doing great. Let's solve today's Leetcode problem 474 ones and zeros. You are given an array of binary strings and two integers m and n. Return the size of the largest subset of strings such that there are at least m zeros and n ones in the subset. Okay, so we in the end we only need the size of the largest subset, right? So let me jump back to here. Okay, so we have been given this array. Okay, I have taken the first example. It has, we are just transforming the given array into its corresponding frequencies of zeros and ones. Okay, so the first string has 1 0 and 1 1, and second string has 3 zeros and 1 1. For the third string has 4 zeros and 2 ones, and so on and so forth. Okay, so once we have this frequencies array, okay, we have to question ourselves that do I really need the actual subset, actual largest subset, or do I only need the size of the subset? Okay, since the problem statement requires only the size of the subset, okay, size of the largest subset, all I have to do is to keep track of the what is the largest subset I have encountered so far. Okay, so let's say I have a magic function which takes these frequencies and the m, n and I. Okay, what do we mean by I? Okay, so this function tells me the maximum size of a subset with at most m zeros and n ones starting at index I and going all the way up to the end. Okay, so let's say since this array is, let's say, 0 based index, if I say I equal to 2, that means starting at index 2 and going all the way till the end, what is the maximum subset, what is the largest subset I can obtain with at most m zeros and at most n ones. Okay, so in the end all I have to do is to return calling this function starting at index 0, right? So what all possibilities I have at a particular given index. Okay, if I'm standing at an index I, there are two possibilities for this particular index. Either I can choose this particular element in my subset, or I not choose the element. Okay, if I don't choose the current element in my subset, then the answer would be the answer obtained by the I plus 1 till all the way till the end. So if I not consider the element at the index I in my subset, then my answer would be the magic function of frequencies m and n will still remain the same because we are not considering the element. So the zeros and ones will not get affected and will start at the next index and go all the way till the end. Okay, and the other possibility is to choose a particular element in my subset. When can I choose an element? Can I directly choose the element in my subset, or is there any restriction? Yes, there is a restriction. They have mentioned that I can only have at most m ones and n zeros, right? M zeros and n ones. Okay, so the number of zeros of the current element should not exceed m. Okay, so and it should not exceed n, 1 should not exceed n. Okay, if this condition meets, then only I can consider the element at the ith index. Okay, let's take an example. Let's say I'm at index I and my m is 5 and my n is 3. Okay, then I can safely choose this element because if I'm by considering this element I'm not exceeding the criteria. Okay, still I will be left with one more m, one more 0 and one more 1. Okay, so yeah, that is the criteria to consider the element at ith index or not. Okay, if I consider the element at ith index, the number of zeros will be reduced, right? As I mentioned previously, it was 5 and 3. By choosing this particular element, okay, the m's will be reduced by 4 and n will be reduced by 2. So So m will be reduced by the number of zeros at the ith element, and n will be reduced by the number of ones at the ith element. Okay, and we have to get the answer for the next elements. Okay, so if you see the recursive graph of this particular magic function, initially we are starting at index 0. Okay, so this is the size of the array, I mean starting at index 0 and going all the way till the end, and m and n are the zeros and ones. Okay, if I don't choose, then my answer would be from 1 till all the way till the end, and m and n's will not get affected. And if I choose, okay, if I choose, that means I have to get the answer from 1 to 4, and the m's will be reduced by this and n's will also reduce by this. Since I am choosing the current element, my answer would be 1 plus the answer which I get from this particular magic function. Okay, since I am choosing. Okay, and the same way over here, since I am choosing. Okay, so we have answer which is getting from not choosing, and we have also answer getting from choosing an element. Okay, so my overall answer would be maximum of these two. Okay, so answer of this would be maximum of not choosing an element and choosing an element. Okay, so there should be one base case where this equation has to end, right? So if there are no elements to consider, okay, if I go out of bound of this array, that means I cannot get a subset which has m zeros and n ones. Okay, so that is the base case where I have to stop. Okay, so I highly recommend you to implement the recursive solution. Okay, now I will show you the bottom up approach. Okay, where I have done where I've done where I've implemented the bottom up approach. I will show you. Okay, so as I mentioned, I have a frequency array which will be of size of the given input strings, and each element will have a size of 2. Okay, zeros and 1, so that's the reason I have defined size of 2, and then I'm just pre-populating this entire frequencies. Okay, once this is done, so if you see, there are 3 variables in my function. Either m can change, or my n can change, or my I can change. Okay, so m can go all the way from 0 to m, n can go all the way up to 0 to n, and I can go all the way up to 0 to length, right? So I have defined my dp array as the corresponding dimensions. Okay, it has to start at 0 and go all the way up to m. So that's the reason I have taken m plus 1 and n plus 1 and going all the way up to the length. Okay, and then I'm just populating the dp array with -1, so that I can know the corresponding state is whether processed or not processed. Okay, and as I have defined that, I told you, right, there is a magic function which will tell me the answer. So I defined a function called util, which is taking frequencies m, n and I, and I'm also passing this dp array. Okay, so if the answer was already calculated, okay, then I have to return the answer. So there is very easy approach. Okay, uh, to convert the recursive solution into its memoization. Okay, all you have to do is to pass this dp array and add this particular check. If the state is already processed, then you have to return it, and correspondingly you should also populate the state at the end. That's it. Okay, if you're able to figure out your recursive solution, converting it in memoizing it is very simple. Okay, so I've straight away implemented the memoization solution over here. I mean, not memoization, this is the bottom up approach where I've defined the dpr straight away. Okay, yeah, so and then I'm calling my function. Okay, this is also recursive solution. Okay, this is also, I mean, this is also recursive solution with memoization only. Okay, yeah, I'm calling my utility function and passing my frequencies m, n and I plus 1 and my dp array. So the first option is to skipping the current element, and the second option is to consider or not, right? When I can consider if the zeros the current zeros if it is within my restriction or not. If it is within my restriction, then I will choose to consider it. Then accordingly I will reduce my zeros, and accordingly I will increment my answer. Okay, and then I have to take the maximum of both take and not take, and then I have to return it. Okay, so this is basically recursive solution with memoization. Okay, all I have defined is I've just defined this state before itself. I know beforehand how many possible uh, possible states of recursion can happen. That's the reason I have defined it. You can also do it using hash map. Okay, where you can have a hash map with key as a string of m, n and length, and then accordingly you can also do it. Okay, this is basically recursive with memoization. Okay, when I say bottom up approach, okay, you will basically start from the least possible value and try to populate the other solutions. Okay, so when I say bottom up approach, you will come with the leaf nodes and try to calculate the previous try to calculate its parents parent parent value, and then so on and so forth. Okay, yeah, that's all about this problem. I hope you understood the thought process behind this problem. Okay, yeah, do subscribe to my coding channel for more such coding videos. I've noticed that people are not subscribing to my channel but still consuming my videos. Okay, so let's also try to analyze the time complexity and space complexity over here. Okay, so the space complexity would be, since we are doing recursive solution, okay, it will go all the way up to the depth of the tree, and the time complexity would be the order of m, n and I. Okay, where n is basically the length. Okay, so it is order of m, n and the length. The reason being ki we will at least visit all the nodes in the tree for once. Okay, so we will process all the states of this dp array, and then we will return the answer. Okay, so that is what the time complexity is. Okay, with the help of memoization, um, we are trying to reduce the redundant recursion calls. Okay, so that is all about this problem. Yeah, thank you.